Hello students, here we will study the unit named optics in the syllabus. In this unit, we will try to see what is meant by wave nature of light, how the reflection and refraction takes place in light, and what is meant by polarized light. So we will begin with wave theory of light. It was Christian Huygens in 1679 who proposed this wave theory of light. As per this theory, each point in a source of light sends out waves in all directions. 1679 मध्ये ख्रिश्चन हायगेन्स यांनी ही वेव्ह थिअरी प्रपोज केली. या थिअरी प्रमाणे लाईट मधला प्रत्येक पॉइंट सेकंडरी वेव्स पाठवतो बाहेर. याचा अर्थ काय? These are the secondary waves which are given out by each point of the source. So this is a point of the source. असा प्रत्येक point source मधला it will give out secondary waves in all directions. In an isotropic medium. What is meant by isotropic medium? Isotropic medium is a medium in which the physical properties are same in all directions. So this is isotropic medium where physical properties are same. युनिफॉर्म आहे सर्व डायरेक्शन्स मध्ये हे मीडियम. द मीडियम इज युनिफॉर्म इन ऑल डायरेक्शन्स. That is why the light will travel with same velocity in this direction. It will travel with same velocity in direction. In this direction, in all directions, the light will travel with the same velocity in all directions. आयसोट्रोपिक मीडियम मध्ये लाईट वेव्ह ही सगळ्या डायरेक्शन्स मध्ये सारख्याच वेलोसिटीने पुढे जाईल. जर मीडियम एनिसोट्रॉपिक असेल, व्हॉट इज मेंट बाय एनिसोट्रॉपिक मीडियम? एनिसोट्रॉपिक मीडियम which is not isotropic medium. The light will not travel with the same velocity. Here it may travel faster than the direction in this. So this is anisotropic medium. The light will not travel with the same velocity in all directions. एका डायरेक्शन मध्ये वेगळ्या वेलोसिटीने लाईट पुढे जाते, तर दुसऱ्या डायरेक्शन मध्ये लाईटची वेलोसिटी त्यापेक्षा कमी राहू शकते. दिस इज anisotropic medium where velocity will not remain same in all direction. We are talking about an isotropic medium where the velocity is same in all directions. So what will happen in this isotropic medium? These waves are traveling with the same velocity in all directions. So the velocity of light is this 3 into 10 raised to 8 meter per second. It is uniform in all directions. because the medium is isotropic. So what will happen then? This disturbance will reach this disturbance will reach simultaneously to all points which lie on the sphere, Why a sphere? Because it is traveling with same velocity in all direction. So these waves which are given out, these secondary wavelets which are given out by this point, they are traveling with same velocity in all direction. So this disturbance, these waves will reach on a surface of a sphere, where what is the point of the center? The center is the source. The source is given out. The source is giving out secondary waves in all directions. These waves will travel equal distance in all directions. What is the distance traveled by these waves in time instant t? In the time t, where the velocity is c, the distance traveled in all directions will be equal to ct in the time instant t. हा जो पॉइंट सोर्स आहे तो सर्व दिशांमध्ये सेकंडरी वेव्स पाठवतो आहे. या सेकंडरी वेव्स सगळ्या डायरेक्शन्स मध्ये c या वेलोसिटीने पुढे सरकतील. सो या सगळ्या वेव्स t या टाइम इंटरवल मध्ये ct एवढा डिस्टन्स ट्रॅव्हल करतील सर्व डायरेक्शन्स मध्ये. सो t एवढ्या टाइम इन्स्टंट नंतर ते सर्वजण सगळे सेकंडरी वेव्स एका स्फिअरच्या सरफेसला पोहोचतील. ती रेडियस काय असेल या स्फिअरची? तर रेडियस असेल c × t. आणि सेंटरला काय असेल? सेंटर विल बी दी पॉइंट ऑफ source of light. So this is called as a wavefront. This sphere will be called as a wavefront. It is a locus of points where all points have reached all secondary waves have reached after time interval t, and they are in the same phase of vibration. हे सगळे जे पॉइंट्स आहेत या स्फिअर वरचे हे व्हायब्रेशनच्या सारख्याच स्टेजला आहेत, कारण त्या सर्वांनी सारखंच डिस्टन्स कव्हर केलेलं आहे. सो दिस स्फिअर is called as a wavefront, spherical wavefront. The shape of the wavefront will depend upon the source of light used. The shape of the wavefront will depend upon the source of light used. So let us see first type of wavefront. We have said that the type of wavefront will depend upon the source used. Now let us see what are these types of wavefronts. The first is spherical wavefront. Consider the case where the source of light is a point source. It is a point source. So we are discussing the spherical wave. We are discussing the isotropic medium. So when the point source when the source is a point source, this is a point source of light. The medium is isotropic medium. So this point source will give out the secondary waves in all directions which are traveling with equal velocity in all directions. So see, these will be the spherical wavefronts which are given out from this point source. Every point which lie on a sphere, it consists of all disturbances which are in the same phase of vibration. So एका स्फिअरवरचे सगळे जे डिस्टर्बन्सेस आहेत ते व्हायब्रेशन्सच्या सारख्याच फेजमध्ये आहेत. त्या सर्वांनी इक्वल डिस्टन्स ट्रॅव्हल केलेला आहे पॉइंट सोर्स पासून टी या इन्स्टंट मध्ये. सो दॅट all disturbances which will reach this sphere after traveling equal distance after time interval t. So every spherical surface will be a spherical wavefront as all points of this surface will be in the same phase. This is a spherical wavefront given out by a point source O in an isotropic medium. जेव्हा सोर्स हा पॉइंट सोर्स आहे तेव्हा तो मीडियम मध्ये आयसोट्रोपिक मीडियम मध्ये स्फेरिकल वेवफ्रंट्स देईल. What will happen when the source of light is not a point source but it is a linear source? This is the source of light. Say O dash. So this is not a point source now, as we have seen in the earlier case. This is a linear source. So how will be the wavefront developed by this linear source? Every point of the source will give out the secondary waves in all directions. Every point of the source will give out the secondary waves in all directions. So these secondary waves will travel with the equal velocity in all direction. So they will travel equal distance in equal time interval in an isotropic medium. So see, for example, I have shown you these 5 points of the linear source which are giving out the secondary waves. These secondary waves are traveling with equal velocity in all direction. So how will be the wavefront developed now? See that it will be the cylindrical wavefront like this. It will be the cylindrical wavefront. See, this figure shows the cylindrical wavefront where O dash is a linear source of light. So this is giving out the secondary waves in all directions. Each point of the source gives out the secondary waves in all directions. So if we connect all these points after time interval t, they will lie on this cylinder. Hence the corresponding wavefront is a cylindrical wavefront. जर सोर्स हा लिनियर सोर्स आहे, तो पॉइंट सोर्स नाहीये, तर त्या केस मध्ये काय होईल? एव्हरी पॉइंट, प्रत्येक पॉइंट जो आहे सोर्सचा तो सेकंडरी वेव्स देईल, ज्या सर्व डायरेक्शन्स मध्ये सारख्याच वेलोसिटीने ट्रॅव्हल होतील. सो काही टी या काळानंतर आपण जर हे सगळे पॉइंट्स जोडले तर आपण एक सिलेंडर मिळवू शकतो. सगळे पॉइंट जोडल्यानंतर आपल्याला एक सिलेंडर मिळेल जिथे की सगळे जे वेव्हफ्रंट्स आहेत त्या व्हायब्रेशन्सच्या सारख्याच स्टेजला पोहोचलेले असतील. म्हणून रिझल्टंट वेव्हफ्रंट ही सिलेंड्रिकल वेव्हफ्रंट असेल. Now, if the source is a point source or a linear source, as we have seen in the earlier case, but the source is kept at infinite distance. The source is kept at infinite distance. Then what will happen? Consider that this is a source. This source can be a point source or it can be a linear source O dash, or it can be O, a point source. The waves will be given out. The spherical waves will be given out. What will be the, after infinite distance, what will be the small portion of this spherical wavefront? This, see, in this region, in a square, in a rectangle, what is this region? This region of the spherical wavefront is a plane wavefront because the distance from the source is infinite. So the small portion of all these spherical wavefronts, small portion of all these spherical wavefront will tend to be a plane after infinite distance. The same thing will happen in case of a cylindrical wavefront also. So these cylindrical wavefronts, these cylindrical wavefronts which will be given out, right, through by this linear source of light. So this is small portion of the wavefront in the small region after infinite distance. After infinite distance, the small portion of this cylindrical wavefront also will be a plane wavefront, right? So this first paragraph says all this. If a point source or a linear source is kept at infinity, then the portion of a cylindrical or spherical wavefront in a limited region will be a plane wavefront. Thus, when the source is at infinite distance, then the resultant wavefront will be the plane wavefront here. This is a plane wavefront. This is a spherical wavefront, but after infinite distance in a small region, the spherical shape tend to be a plane shape. The same thing will happen about the cylindrical wavefront also. After infinite distance, this cylindrical wavefront will give us plane surface in a limited region. This is a plane wavefront. म्हणून जर सोर्स लिनियर असेल किंवा पॉइंट सोर्स असेल, जेव्हा तो इनफायनाइट डिस्टन्स वरती ठेवलेला आहे तेव्हा रिझल्टंट वेव्हफ्रंट ही प्लेन वेव्हफ्रंट असेल. In all these three cases, in case of a spherical wavefront, cylindrical wavefront, or a plane wavefront, always we have seen that the direction of propagation of light is perpendicular to the wavefront at every point. A line drawn perpendicular to the wavefront is called a ray. So, if it is a spherical wavefront, then what is the direction of propagation? This is a spherical wavefront. the direction is this, perpendicular drawn at this point. This is a cylindrical wavefront. What is the direction of propagation of light? At this point, it will be propagating in this direction at this point. So, always it is perpendicular to the wavefront at every point. This is a plane wavefront which is propagating in this direction. So, what is the direction of propagation? It is this direction of propagation, perpendicular to this plane. So, in all cases, can be a spherical wavefront, can be a cylindrical wavefront, can be a plane wavefront. The direction of propagation of light is always perpendicular to the wavefront at every point. So, students, what we have seen up till now? We have seen Huygens wave theory. What is Huygens wave theory? Every point of the source gives out secondary waves in all directions. Every point of the source gives out secondary waves in all directions. What is the next point we discussed? Wavefronts, types of wavefronts. The types of wavefronts will depend upon the shape of the source. So what types we have seen? Spherical wavefront. When the source is a point source. The second type, what we have seen? Cylindrical wavefront. Cylindrical wavefront when the source is a linear source. And the third, we saw what is a plane wavefront, how it develops. Plane wavefront. It will develop when the source can be a point source. It can be a linear source at infinite distance. So, thank you, students.